Hello Humanoids, this is Hash Robotics and it's me Harishankar. I hope everyone is doing good. Well, in the previous video, we did see about making and assembling of this little guy, Pico Hash. Now, in this video, we are going to see how to assemble the remaining electronic components along with the circuit connection. Next, I am going to explain about all the coding part. Then we are going to see how to create a facial expression of the robot using OLED display. Before going into the video, if you did not subscribe the channel, please subscribe Hash Robotics for more robotic project videos. Like and share the video. If you have any doubts or suggestions, you can ask me in the comment section. Let's see how it's done. This is where we left in the previous video. We saw how to assemble the robotic parts without any major components. Now in this video, we are going to assemble those components and make it work as a fully functional robot. Before that, I'll just remove the front and back covers. This is the full circuit diagram of the robot. You can also get the image from the link in the description. I am using this small PCB board and soldered female header pins to mount the Pico module. Next, I have soldered 4 female header pins separately, and it is connected to Pico module power 39th pin, ground 38th pin, data 1st pin and clock 2nd pin, so that it will be easy for us to connect and remove the remaining circuits. Once it is done, we can assemble the circuit setup in front part of the robot. This is another PCB board. Here I have attached PCA9685 servo drive and 2 separate female header pins. Here all modules, power, ground, data and clock pins will be connected to each other. The connections which come from the Pico will be connected here. From there it will be connected to this header pin. From this header pin we can get the connection for OLED display. Power, ground, data, clock. This is how we need to connect. Next, the connection continues from this header pin to the servo drive. To power up the Pico module, I am using the 5V out from the servo drive. And for servo drive, 12V battery will be connected. Make sure that the connections are proper, otherwise you will not get proper output. We can use jumper wires to connect both the PCB boards. Now we can start assemble the remaining parts, buck converter and OLED display and few jumper wires. Next, we'll start assemble the OLED display with head part. Use M3 small screws along with the washer to fix the OLED display. Now fix the PCB board in the 3D printed part and assemble it with the front part of the robot. Use M3 10mm screw for the assembly. Similarly, fix this PCB board with the 3D printed part and assemble it with the back part of the robot. Once the PCB board is assembled, now we can start connecting the servo motors with the servo drive. Refer the circuit diagram to make sure which servo motor needs to be connected to which PWM pin of the servo drive. Now use the jumper wires to connect the Pico module with the backside circuit. I am using 4 jumper wires for power, ground, data and clock pins. Now the other end of the jumper wire I am connecting at the back circuit like this. For now, I'll just remove the power pin. After uploading the code, you can connect again. Next, we'll connect the head part. Use the jumper wire to connect the OLED display with the main circuit. Now this is a small switch that I am going to use to on and off the robot. Now we can solder the switch along with the buck converter. For that we need some wires. The output of the buck converter will be connected to PCA9685 servo drive. And the input will be connected to 12 volt battery along with the switch. After soldering, you can connect the 5 volt out from the buck converter to the servo drive. Before connecting the buck converter to the servo drive, use the multimeter and adjust the output voltage to 5 to 6 volt. Please make sure that the output voltage does not exceed above 6 volt. Now use the double side tape to fix the buck converter to the back cover. Now we can connect the OLED display to the main circuit. As you can see, I just tied all the wires using cable tie. So it looks good now and we can save more spaces. Now, using micro USB cable, connect your robot to your system. For now, I'll just remove the connections. Press the boot button before connecting and release the boot button. Once your Pico is detected by your system, open Tony IDE and install MicroPython. Now the MicroPython has been installed into your Pico. As you can see, I have already uploaded the coding into my Pico module. You can get the link for the coding in the description. Please check. This is the main file. We'll come later for this one. To control the PCA9685 servo drive, I found some libraries online. PCA9685 and servo. These two Python libraries are required to control the servo motor. If you want to learn more about these libraries, I mentioned a link in the description. You can check. In this servo.py library, I have also added some custom methods for Pico Hash. Next, there are two more additional libraries for OLED display. They are SSD1306 and SH1106. If you are using 0.96 inch display, then you can use SSD1306. Since I am using 1.3 inch OLED display, this SSD1306 will not support. So I found alternative library, which is SH1106 library. All the movements of the robot are manually calculated. There are some predefined few movements I have written in hashmoves.py. If you want to add more actions, you can add it here. And next, this is hash facial expression file. This is where I have configured all the facial expression for OLED display. The text that you are seeing in green color, they are byte array format of all the images. By using this image to byte array Python script, I have converted all the images into byte array format. Next, this I2C address find file. By using this Python script file, we can find the address of the connected device to the Pico module. There are some predefined facial expressions I have configured here, like happy face, sad face, sleep, blink, and etc. You can also display a good animation by displaying the facial expression in the for loop. Now, let's see how to convert this image into byte array format. First, open the image to byte array Python file in any of the editor. I am using Visual Studio Code. You can also use the command prompt to get the good result. Now I'm going to just open the image files. These are some facial expression emoji file that I found online. I have also added these images. You can find the link in the description. Once you got the image, you need to crop the expression into 128 into 64 pixels. For example, I'll just convert this test file. Now copy the file path and paste it in the path to image path location. The image format can be either JPG or PNG. Make sure the name of the image is properly mentioned in the path. Now we are ready to convert. Use the following command to convert the image into byte array format. In the file path location, we need to use forward slash instead of backward slash. Once you changed, use the same command. As you can see, the image is converted into byte array format. Now copy the converted byte array text and you can paste it in your code. You can follow the same steps to convert your own expression. This is the main Python file. Here I have imported all the required files. Here I am mentioning data and clock pins. Next I am creating an object of I2C by passing the data and clock pins. Next here I am creating an object of hash facial expression and hash moves. Next, I am initializing the OLED display by passing the I2C object. Here, you can set the additional configuration setting like width, height, and rotate, fill, and etc. Next, I am initializing the hash moves. Here, I am creating an object of PCA9685 and servo. Then, I am calling the initial position method. This initial position method will be present in servo.py library along with the default methods. Once the method is called, all the servo motors move to initial position stage. Once the robot is moved to initial position stage, next I am calling the default face expression. This will set some initial expression to the OLED display. Next, I am calling some facial expressions and hash robotic moves which I configured. Now we can upload the code and check the robot. Before that, I am just opening this I2C address finder. As you can see, there is no device was connected now. Now I am going to connect the ground, data and clock pin to the Pico module. And I am also connecting the 12-volt battery to the PCA9685 servo drive. Sorry, I wrongly connected data and clock pins. Once I fixed that, I am trying again now. As you can see, the I2C address of OLED display and servo drive are detected now. Now, to check the robot whether it is working or not, I will just enable the say hi movement. Now I am going to run the code. As you can see, it is working as expected. Now we'll just enable all the functions and upload. Once the robot is switched on, the Pico will execute the main.py file. Once the code uploaded into the Pico, just remove the micro USB cable. Now I'll just assemble the battery inside the robot and connect 5V out from the servo drive. Once all done, switch on the robot and make sure everything is working fine. Then assemble the front cover. Here some of the facial expression and functions of the robot. For full functional video, I have attached the link in the description. Please check and enjoy the video. Thanks for watching the video. In the next one, we'll see how to add a Bluetooth module to control the robot using Android application. Keep supporting and keep learning. Thanks. Bye.